Hey guys, first of all, thank you for watching. Today we're going to be talking about the normal distribution, and I'm just going to do two examples. Both are a little different. So yeah, but please don't forget to subscribe, like, and if I'm doing anything that you feel like could be improved, just shoot me an email. I'm talking to my students. Shoot me an email if you want me to do another video. Just tell me the topic and I'll do it. So today is the normal distribution. So there's just a few things that you should know about it before we actually do the math. First things first, it's also known as the bell curve. So shaped exactly like a bell. Second, it's the most important continuous distribution in all of statistics. This curve is found all throughout nature when studying animals, plants, human behavior, you name it. Like, this curve comes up all the time. Like, it's actually pretty incredible how often it occurs naturally. And one of the most interesting things to study is people. So this curve, when they graph their data, actually shows up like all the time. The third thing, it is symmetrical. So there's a line of symmetry when you draw the curve. And it is cut straight down the middle. The third or the fourth thing, the line of symmetry is equal to the median. The median, the mode, and the mean are all equivalent in this case. And they're all symbolized by the Greek letter mu, so it looks like a line with a U attached to it. The standard deviation, that's the Greek letter sigma. That's just something you're going to need to know. And then the empirical rule, also known as the 68, 95, 99.7 rule. I do want to talk about that rule before we actually finish A through D. But the empirical rule it tells us the building blocks of this graph. And so it really helps us determine the probabilities and all that stuff. So you're going to need to know the most important things. You're going to need to know the fact that it's symmetrical and that this is cut straight down the middle between the data. You're going to need to know the mean or mu. And then you're going to need to know the standard. You're either going to be given the standard deviation or you're going to have to find it. And then finally, you're going to have to memorize this rule, the 68, 95, 99.7 rule, the empirical rule. So first example, given a mean of 98 and a standard deviation of 11, draw the normal curve, label the horizontal axis, and find the percentage of scores. So you're finding 4 percentages. The percentage of scores that land between 76 and 120, the percentage of scores that land above 109, the percentage of scores that fall below 87, and then lastly, how many students out of 800, the sample size would be 800, how many students out of 800 would score between 87 and 120. And so I went ahead and I drew the graph. This is the setup for every normal distribution problem. If you see normal distribution, if you see the word normally distributed, you draw this bell curve. You draw this axis, these two axes. You draw a curve that you want it to look kind of symmetrical. And you make sure that the line down the center, the line of symmetry, is denoted by mu. Okay? And so there's 1, 2, 3, 4, 5, 6 evenly spaced hashes. And so I don't know if you can see, if it's too small, I'm sorry. This says mu minus 3 sigma, mu minus 2 sigma, mu minus single sigma, or mu minus sigma. And then here's just mu, and then mu plus a single sigma, mu plus 2 times sigma, and then mu plus 3 times sigma. And so I have them here in bigger. And so after you set it up exactly like this, with the horizontal and the vertical lines and the bell curve, this is just your setup. Okay, so now after you've drawn the graph and everything, because this is all you're really going to need to know for answering all of these questions, you're going to find these 6 values. Okay, and these 6 values land on this horizontal axis, and it goes in chronological order. So from smallest to biggest. So it's actually really nice because most of the time they give you the mean and, the standard deviation values. And so here they said that mu, the mean is 98, and that sigma is 11. So sigma is 11 and mu is 98. And so now all we have to do is we just plug in these values here to find the 6 missing numbers that will go on the horizontal axis. Okay, so, and notice where I put mu. I put mu right in the middle because it's gonna go right in the middle. So first thing, mu minus 3 sigma. So I'm just gonna plug in my numbers. Mu is 98, so that's 98 minus 3 times 11. What is that? 98 minus 33. That is 65. Okay? Next, mu minus 2 times sigma. 98 minus 2 times 11. So it's just simple, it's just simple multiplying and subtracting. 98 minus 22. Okay, so that's 6, and then that's 7. 76. Mu minus 1 sigma, so just 98 minus 11. And that would be 87. And we already know what that is. And so now we're going to add, so that's 98 plus 11. I believe that's 107. 98 plus 2 times 11, so 98 plus 22. That's 10, that's 120. And you can also go down here. So if you notice, they're literally just increments of 11. So that's 98 plus 3 times 11, so 98 plus 33. And that's the same as 120 plus 11. I don't know if you've noticed, but that's what it gives you every single time. So that is 131. So these are the values. Yeah. Okay. These values are increments, so it's counting by 11 at a weird starting point, but at the same time they're still going by 11. And so now once you have your values, you just put them in numerical order. Okay, so here, and we haven't talked about how this is going to come into play yet. I do want to just show you, it's always really, really good to label your diagram first. Okay, and so this, what did we say? We said it's 65. So that's 65, 76, 87, 98, 107, 120, and then 131. Okay, so our horizontal axis is done. Now I want to talk about the 68, 95, 99.7 rule, the empirical rule. The empirical rule tells us the percentage of data that falls in between these ranges. So since the line of symmetry, it's what it cuts, all lines of symmetry cut the whole, the diagram in half, right? Any diagram, it gets cut in half by the line of symmetry. So since this is our line of symmetry, it is logical to say that from here onwards is 50% of the data, okay? So let's do that. This, from the line all the way to the right, that is 50% of the data. Same thing over here. That's 50% of our data. So now these numbers come into play. So the empirical rule says that between one total standard deviation, so between the -1 times sigma, all the way to the +1 times sigma. So from here to here, the empirical rule says that 68% of data falls in this range, okay? So 68, this is 68%. Let's do 68%. 68%. Now, the 95 portion, the empirical rule says that from here to here, so between two standard deviations, the twos, then from -2 to +2, this is where 95% of our data will fall. Okay, so that is 95% from there to there. And then lastly, 99.7, kind of a weird number, but this is how it's gonna look. Oops, it's not perfect. 99.7%. So adding these numbers up will give us 99 point, I'm so sorry. This is 99.7 right here. So 100 minus 99.7 is 0.30. 0.30 divided by 2 is 0.15. So I'm going to go ahead. This is 0.15. That is so ugly. This is 0.15. So just how I divided that like missing chunk by 2, I can easily divide this by 2 because this is our line of symmetry. The line of symmetry cuts everything in half. So this becomes 34%, 34%. Okay. 34 plus 34 is 68. And now here, I subtract. What you can do is you can subtract 95 from 68 and then divide that by 2. Or you can just remember the fact that this would be, is it 12.5 or 13.5? I want to make sure. Yeah. 13.5%, and this is 13.5%. And then here, this last chunk, 2.35, 2.35%. Let me do that. Okay. And then this is 2.35%. So if you add up all these percentages, this 0.15 plus 2.35 plus 13.5 plus 34, you're going to get 50%. Same thing over here, you're going to get 50%. So if you want to add up all these little increments, you will get 100%, just like you would get 100% adding 50 and 50. So we've just totally like labeled our graph and our line and everything. That's the hardest part, okay? So now let's look at the questions. So part A, find the percent of scores that fall between 76 and 120. That fall between 76 and 120. So all you do is you add up those percentages between these two numbers. So it would be 13.5 plus 34 plus 34 plus 13.5. Okay. Also known as, if you have the empirical rule memorized, from here, from 76 to 120, that is 95. That's within 2 perfect standard deviations. So that would be exactly 95%. Or you can just add them all up and you don't have to, remember the fact that that's 95. So that's our answer for part A. 95% of our data will fall between 76 and 120. Okay? And you just add up those percentages. So now let's do above 109. What's the percentage of people that will score above 109? Oops. 107. It's 100. It's supposed to be 107. I'm sorry. No, that is 109. What? There we go. 109. Sorry. So between above 109. So you're adding everything after 109. So that would be 13.5 plus 2.35 plus 0.15. So let's see. Plus 2.35 plus 0.15. 16%. Okay? Below 87%. Or below a score of 87, I'm sorry. Below 87, so that would be 13.5 plus that. We just did that, so that's also 16%. Now the last one. How many students out of 800 score between 87 and 120? So we're going to do the same exact thing as A, B, and C, and then we're going to do a final step to convert that into a people value. So between 87 and 120. So we're going to add these percentages. So that's 34 plus 34 plus 13.5. I'll do that here. So that's 68 plus 13.5. So that's 0.5, that's 11, so that's 6, 7, 8. So that's 81.5%, okay? 81.5%. But I need the number of students. I need a nice whole number that's talking about actual human beings. So I am going to convert this into a decimal, not a percent. So turn it not into a percent. I know it's a decimal already, but we're going to get rid of that percent sign by moving it 2 places to the left. So the way how I find my answer is 800 times 0.815, and that will give me my answer. 800 times 0.815. 652. So 652 students. 652 students out of 800 are going to score between 87 and 120. Okay? So I know it looks like a lot, but I feel like once you break it down into steps, then I really feel like it's way more doable. And I feel like once you understand how the percentages are broken up via the empirical rule, then this doesn't look so intimidating. It's not intimidating. It's not. Okay. So go ahead and if you want to pause the video, go ahead and just look at the whole board.